Hey, math people. Area between curves isn't too bad if we can look at a graph. So I think it's best that I do this in this setting so that I can graph everything on Desmos. Of course, you can use your graphing calculator if you can't use Desmos on an assessment. So let's start. Yeah, I make my bed every day. What's the deal? You got a problem with that? Winner start every day when making the bed. All right. First one, I got a parabola, x squared minus 5, got a line, negative 2x plus 3, and then I'm actually provided some bounds, which is very nice of them, from negative 2 to 3. I want to find the area between these curves, and the best way to do that is through graphing. So you would graph this on your TI, and these problems right here would cause no issues. The second two problems we do will cause issues. So we're going to have y is equal to negative 2x, plus 3, and then x is equal to negative 2. This is going to be my first bound, so my lower bound for one of the integrals, and x is equal to 3, which is going to be my upper bound for one of the integrals. The only thing that we're looking for in between these two is when I potentially switch my top curve to a different top curve, and that absolutely happens. If we look at this graph, I'm looking at these two small areas right here. That's what I'm looking to find the areas of, the added areas between them. We cannot integrate this from negative 2 to 3. We can't just do it in one nice integral and call it a day. The way we integrate with respect to x is we do top minus bottom. So we would integrate this top expression minus this bottom expression. However, top switches from a line to a parabola at this x value of 2 comma negative 1. How would we find that ordered pair 2 comma negative 1? Well, if you're in your calculator, you would just find the point of intersection. If you have a TI-84, you would do second intersect, and then click the two lines, and sure enough, it'll give you 2 negative 1. If you want to do it algebraically, fret not, we can do that really simply. We just set these two expressions equal to each other and solve. So we would just say, all right, well, x squared minus 5 is equal to negative 2x plus 3. It's a quadratic, so set it to 0. We're going to get x squared plus 2x minus 8 is equal to 0. That's factorable. We get x plus 4, and then x minus 2 is equal to 0. And sure enough, the line crosses at x is equal to negative 4, which we don't care about, by the way, because that's outside. That happens. Oh, no, actually, we're neutral about it, because that's actually right. No, we actually don't care about it. I go back to my initial statement. That's all the way over here, and that's outside our bounds of integration. We were provided the negative 2 and 3. So I don't really care about this one. I do care about this one, though, a lot. Here at x is equal to 2, that's when it switches from the green line being up top to now the blue parabola being up top. So I do have to be careful. When I integrate this, I will have to break this into two separate integrals. Cannot do this in one integral. I was trying to collect it all here. There we are. All right, so let's set up our integrals. What I want to do is top minus bottom for when we're integrating with respect to x. So let's worry about our bounds here. So I'm going to say the area is equal to, my leftmost bound occurs at the provided x value. X is equal to negative 2. So that's what I'm going to take. And my line is above the curve all the way up till positive 2. So that's when I switch, and sure enough, put that positive 2 there. So it's going to be line minus parabola. So you're going to have negative 2x plus 3 minus x squared minus 5. And note how I'm doing the parentheses, because I just want to very clearly communicate to the reader that, hey, it's this line minus this parabola. Don't forget your dx. And then plus, we got to keep going, because that's just that first area right here. I want to find this area, this like triangle-ish looking thing. So that's going to go from 2, because I'm going to start right off the bat at 2. That's where I left off. And I'm going to end at the other x value they gave me, which was 3. So the integral from 2 to 3, this time around parabola's up top. So x squared minus 5 minus negative 2x plus 3 dx. Throw all this into a calculator, and you should get, I'm looking for the answer, and you can integrate this by hand, by the way, too. You should get 30. So this total area of this section plus this section is 30. So you can math 9 this if you have a TI-84, and just do them as two separate integrals and then add up those values. Or you can do this by hand. Nothing's stopping you from doing that. This is actually not too bad by hand. Okay, for the next one, a little sloppy, so I will write it more officially over here if you can't read that. It's a negative cubic and a negative quadratic, and it looks harder. I would argue it's not, because there's only 2 lines. They just don't give you any bounds, so you do have to do a little bit of solving. Nothing too crazy. Let's graph them. So negative x cubed over 2. This is going to be our cubic curve, minus x squared over 2. And then plus 2x, okay. Y is equal to negative x squared over 2. We want to find the points of intersection. Area between the curves, I think, is very straightforward. Just this little bean-looking thing, and then this little Nike-looking symbol, but upside down. So I'll zoom in and get a better view of that. Yeah, so how do I figure out these points of intersection? You can use a calculator. You can simply use a calculator and then do the second intersect. Sure enough, you get all these values. However, let's just say I had to do it by hand for whatever reason. It was a non-calculator assessment. So in which case we find where these intersect by setting them equal to each other. We would just say negative x squared over 2 is equal to negative x cubed over 2 minus x squared over 2 plus 2x. I don't like these over 2s. I'm going to multiply everything by 2. So I'm going to have negative x squared is equal to negative x cubed minus x squared plus 4x. I'm going to now add the x squared onto both sides. So I'm going to get 0 is equal to, I'm just going to factor out a negative, x cubed minus 4x. And we'll just divide both sides by -1 just to get that negative out of there. And I'll also factor out an x. I'll say, well, okay, if I can factor out an x here, I got x squared minus 4 on the inside. And this is a pretty expression to solve for. I get x is equal to 0 here. And on this side, I get x squared is equal to 4. So I get plus or minus 2. And sure enough, that's exactly what you see on the graph. You see 0, -2, and 2. Well, here's 0, -2, and 2 as our x values. And it happens to also be our y values too, but that's perhaps a coincidence, we'll say. So we would have to figure out what's higher and where. If it wasn't a calculator assessment, you would just plug in 1 and -1 and just see which one's higher. But we have the visualization, so let's take advantage of that. So I'm going to erase all this algebra. I now know that my bounds are going to have a lot of 0s and -2s and 2s. So the area is going to equal to, area is going to end up equaling to here. So from -2 to 0, the quadratic is higher. So we're going to do the negative x squared over 2 minus the cubic. I'm just going to write this as fast as possible, foregoing any sense of neat handwriting, because you can just see that I'm just copying them down. And then the second window is from 0 to 2. We're taking the x values because we're integrating with respect to x. That dx on the end here is really important because you can integrate with respect to y, which is perhaps what we're doing next. So from 0 to 2, we now have the cubic on top of the quadratic, so we're just flip-flopping these positions. So it'll be negative x cubed over 2 minus x cubed over 2 plus 2x, and then this time around I'm subtracting off the parabola, which was a negative x squared over 2. And then don't forget that dx. This should be the proper setup to help you find that area. And of course we're going to cheat here because I don't want to type that in a calculator. I already did it earlier. You should have gotten 4, just the number 4. It's a nice pretty area. All right, so integrating with respect to x, nothing too crazy. It gets crazy when you integrate with respect to y, so let's see what that looks like next. Okay, so something should be a little fishy if your equations are solved in terms of x, because they're solved where x is isolated, because that should be a giveaway that we might be integrating with respect to y. And that's not too crazy. It just gets annoying when you're typing this into a calculator because you would have to solve for y, and here very clearly that's very difficult to solve for y. So doing this kind of the correct way, using a calculator, is just annoying here. What you could do is you can switch all the x's and y's and then just solve it in your calculator that way, but let's do it the official way. It's a little nicer that way. So what are we doing here? We're going to type them into Desmos first. So this first one should be like a sideways parabola. Instead of the x being squared, it's the y being squared. So, and then plus 5. Looks like I got to zoom out a little bit. Yeah, you guys can see that. Good. All right, and then I have x is equal to negative 2y. It's a line. And then I have y is equal to negative 3. And I have y is equal to 0. All right, so those are my bounds, or at least those are going to be a portion of my bounds. I'm looking for these two areas right here, because those are between all my curves. When we are integrating this way, we're going to be integrating with respect to y this time around. So we're going to have a dy at the end, not a dx. And the way that we think about these problems is no longer top minus bottom, it's right minus left. And it's sort of like top minus bottom if you just tilt your head and you kind of view it this way, or if you rotate it counterclockwise 90 degrees, it still kind of is top minus bottom, it's just not anymore. So it's right minus left. You can view it however you want. You can either do top minus bottom with a rotation, or you can just simply do right minus left without any rotation. So we're going to do right minus left. At first, the parabola is at the right, and then the line is to the left in this little section. And then the line is to the right, and the parabola is to the left in this larger section. So we have to do it that way. We have to split it up again, and we have to find this point of intersection. Of course, you can, if you're on Desmos, you just click it. If you're on your calculator, though, it's hard to graph these in the first place. In fact, many calculators, they want you to graph it in terms of y. So fret not, if this was a non-calculator, not an issue. We just set them equal to each other. Nothing crazy. So let's set these two expressions equal to each other. I got negative 2y is equal to y squared plus 4y plus 5. Adding that 2y on over. I get 0 is equal to y squared plus 6y plus 5. You can integrate this. You get y plus, or integrate. I'm doing way too much calculus today. Factor. You end up getting y plus 5 times y plus 1. Is that good? Yeah, it's good. So you get two solutions from this. Y is equal to negative 5 and y is equal to negative 1. And we have to think about which one's like more important. So it's the one that's going to be definitely inside your bounds. What you could do is you can actually take both of these and you can plug them in and see which one's going to be in between your y values. But also, we can just be smarter here. We don't have to plug it in at all. I know that my bounds, since they were provided as negative 3 and 0, which of these are in between those values? Well, it's your negative 1. The negative 5 is outside of it, and I'll show you graphically. So there's 2 points of intersection. Here's that negative 5. It's a y value this time. And here's that negative 1. Again, it's a y value. This negative 1 is inside our bounds. This negative 5 is not, so I'm actually just straight up ignoring him. And I'm going to be playing around in this window. So I am removing... Man, I can't grab this. All right, there we are. I'm removing all this stuff. Algebra 1 is great, but no longer required. Let's do calculus now. So we're going to set this up as two separate integrals. So the area is equal to, let's integrate. So again, it's y this time around, and it's right minus left. What is our, going to be our lowest output, our lowest bound? It's going to be all the way down here. So it's going to be at a y value of negative 3. And then we're going all the way up to that y value of negative 1 we found earlier. So negative 1 there. And it's right minus left, so we're doing the bigger area first. So it'll be negative 2y minus the parabola, which is y squared plus 4y plus 5. All right. Now we're going to pick it back up on negative 1, and then we're going to go up to our highest bound. So we're still going up, 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 and then all of a sudden we stop right at 0 thanks to this upper bound provided to us. So from negative 1 to 0, it's now the parabola up top or to the right and the line to the left or down below. So with this said, we're going to have the parabola first. It'll be y squared plus 4y plus 5. And then we're going to subtract off the negative 2y. Oh, and I didn't tack on the dy. Whoops. So this is dy, and then this is dy. So you should see both of them now. Don't forget your dx and dy. It's really easy too. All right, so if we just trust our calculators, we can now just math 9 this. And if you want to write the y's, you can. If you want to write the x's, you can. It doesn't matter how you do it on a TI-84. What should you get? What should you get? You should, if you do this properly, get 23 over 3. Yeah, that looks good. 23 over 3. So I'm going to write that down. So not as elegant of a number in the last two. That was more so luck. But obviously you should get a positive number. That's like dead giveaway. One thing you should be wary of with these area and eventually volume problems, make sure the answer makes sense. If you get a negative number, that makes no sense. If you get an extremely weird number that's like ultra mega big or ultra mega small, that's also probably not right too. So just kind of eyeball it, make sure it makes sense to me. Yeah, sure, that makes sense. That's like about 7 or something like that. Sure, that seems pretty feasible that these areas add up to 7 or 8, whatever it may be, 7.67. So yeah, let's do one more, and we'll do the hardest one now. All right, for our last problem, x is equal to a cubic and x is equal to a quadratic. This time around, it's just clearly here we're going to end up solving this area in respect to y. We're going to be integrating with respect to y here because these are isolated for x. And again, that makes it harder to type into a TI, so this is manageable without that. And I can show you how right now. So let's pretend, let's not even graph this. How would I find those points of intersection? Because I don't have additional nicely provided bounds like I did in the last one, and it doesn't solve out to a nice simple number, or at least it may not immediately on simple inspection. So let's set them equal to each other. Let's see if that might help. So I'm gonna have y squared is equal to 2y cubed plus 3y squared minus 4y. Okay, I'm gonna move this y squared on over. So I'm gonna get 0 is equal to 2y cubed plus 2y squared. And then that's a minus. I don't know why I was making that a plus. Minus 4y. Okay, I want to factor some stuff out. I can factor out a 2 and I can actually just divide out a 2. So all these 2's go away, and this will turn into a 2. Because 4 divided by 2 is 2. So I'm dividing everything out by 2. And I'm also factoring out a y. So I'm going to get y on the outside, and then y squared, what is this going to be? Plus y minus 2 on the inside. So I did a 2 for 1, I divided out a 2, and I factored out a y. So that actually brings me to an easy first solution. Y is equal to 0. This is going to be the moment where they intersect. And this is going to be another moment where they intersect over here. Y squared plus y minus 2 is equal to 0. Yeah, I think this is factorable. And if it wasn't factorable for all these problems today, I think that they were all nice and pretty and factorable. You would use quadratic formula, which is unfortunate, but you know, something that can happen. So is this nice and factorable? I sure hope it is. We get, yeah, you get y plus 2, yeah, plus 2, and then y minus 1. So here we get y is equal to negative 2. Here we get y is equal to 1, and then we have y is equal to 0. Makes sense that a quadratic cuts through a cubic curve 3 times. So let's actually kind of confirm our suspicions. So this time around we're doing the algebra first and then confirming our suspicions. We can still do this by hand completely, but it's nice to view this visually. We get x is equal to 2y to the third plus y squared. So that's a cool looking cubic, and then minus 4y. And then our other one is y is equal to y squared. So when I click these, the y value should be 0, negative 2, and 1. So here's the 1, here's the 0, and here's the negative 2. So sure enough, it matches. I'm looking for this small area right here and then this larger area right here. Let's do it. I'm going to erase all this. Nope. I'm going to erase all this algebra. And let's start by writing the calculus. So what is this area going to equal to at the end of the day? This area is, that was me combining an E and an A at the same time, area. Okay, so what's the rightmost in the bottom expression? So we're going from negative 2 to 0. because we're integrating with respect to y. So I'm going to start doing that. Where am I? Here I am. So from -2 to 0, what is my rightmost expression? Because that's going to be the first. It's going to be the cubic. So it'll be 2y cubed plus 3y squared minus 4y. Okay, and then we're going to subtract off that y squared. dy. Didn't forget it this time. All right, and then we're going to add. We want to start at 0 because that's where we left off. And we want to go all the way to this x value of 1, or y value of 1, even though they're both 1. But we're taking the y values because we're integrating with respect to y. So from 0 to 1, the quadratic is higher or further to the right. So it's going to be y squared minus 2y cubed plus 3y squared minus 4y dy. Ending that parenthesis there. And it's sometimes conventional to put this whole thing in like brackets. I don't know if I've been doing that, but you know, it's just a convention. I've seen it without it as well. Anyway, final answer. What do we end up getting here? So we end up getting 37/6. Well, that's cool. So hey, that's all I have for you. Please continue to math on. I'll do the same. I'll see you in the next video.